In section 2.3, we talk about absolute value equations. So the solutions of an equation of the form, the absolute value of ax plus b equals c, where a is not equal to 0 and c is a positive number. That is a very important part in here. Are those values that satisfy? We've got two different ones. We drop the absolute value bars and write it as is, ax plus b equals c, or we still drop the absolute value bars, but now it's equal to negative c. So the left stays the same, and then we do positive c and then negative c. Now you want to make sure that the absolute value is completely by itself before you start dropping the absolute values and setting it equal to c and negative c. So let's try example number 1 first. The absolute value is completely by itself on the left-hand side. So what we can do is we can now split this into the two different equations. So one, we're just going to drop the absolute values and write it as is. We've got 1/2 x minus 1 equals 5. And then the other one, the left side is going to stay the same, but we're going to set this equal to negative 5. And so the first thing we should do is let's go ahead and move 1 to both sides. And so on the left-hand side, the negative 1 and 1 is going to cancel. We've got 1/2 x equals 6. And we can actually do the exact same thing with the other equation. We can add 1 to both sides. And so it ends up canceling again on the left-hand side. And we get 1/2 equals negative 5 plus 1 this time is going to give me negative 4. And so the next thing that we want to do is we want to get rid of that 1/2. And so what we're going to do is we're going to multiply both sides by the LCD, which in both cases is 2. And so we can do that with both equations because they both have that 1/2. And so what ends up happening is that the 2 and the denominator end up canceling. And we're left with just x, which is what we were looking for. And 6 times 2 is going to give me 12. And on the other one, we got x equals negative 8. And so my answer would be x equals negative 8 or x equals 12. Let's go ahead and try example number 2. We have the absolute value of 3x minus 1 plus 2 equals 5. And so the problem comes into play here. That absolute value is not by itself. So what we want to do is we want to subtract 2 from both sides so that we can get the absolute value by itself. And then we'll just do the same procedure that we had for example number 1. And so on the left-hand side, our 2's are going to cancel. And what we really end up with is the absolute value of 3x minus 1 equals 3. And so now we're going to split into two different equations. We write 3x minus 1 equals 3 by just dropping those absolute values. And then the other one, we're going to write 3x minus 1, but it's equal to negative 3. And so let's start working to get that x by itself. We can add 1 to both sides. And we can do this either simultaneously on both equations, or we can do one whole equation and then move to the next. I tend to just do them both at the same time since a lot of the steps end up being the same. So over with the first equation, those -1 and 1 is going to cancel, and we end up with 3x equals 4. And on the second equation, those 1's cancel, and we're left with 3x equals -2. Now what we want to do is we got to get that x by itself, so we're going to divide both sides by 3. And this is going to be the same for the other equation. We got to get that x by itself, and so we're going to divide both sides by 3. And so for this first equation, we're going to get x equals 4/3, which can't be simplified, so we're just going to leave it. And on the other equation, we end up with x equals -2/3. And so our two answers, x is -2/3, or x equals 4/3. So the solutions of an equation of the form, let's make things a little bit more complicated. The absolute value of ax plus b equals the absolute value of cx plus d. Are those values that satisfy? We've got two options again. We drop those absolute value bars on the left-hand side and the right-hand side, and we get ax plus b equals cx plus d. Or we drop the absolute value bars on the left-hand side, and then we make the other side the complete negative. And so what you'll end up having to do is distributing the negative to both pieces. So let's go ahead and try this with example number 3. We have two absolute values and they're equal to each other. So on one case, we're just going to rewrite it as if there were no absolute value bars. 3x minus 4 equals x plus 6. In the other case, we're going to keep the left-hand side the same, but we're going to make the right-hand side completely negative. And so that's where you're going to distribute the negative to both pieces. So let's just go ahead and do that so we can be done with it. So we got 3x minus 4 equals -x minus 6. And so we want to start solving for x. So let's go ahead and work the entire left-hand problem first. I am going to subtract x from both sides so that I can get it all to one side. And so the x's cancel on the right, and we end up getting 2x minus 4 equals 6. We can add 4 to both sides. And so that ends up canceling on the left-hand side, and we get that 2x equals 10. And the last thing we can do is divide by 2 on both sides. And so we end up getting that x is equal to 5. Let's do the other equation. So this time I'm going to end up adding x to both sides so that I can get it all on one side. And so it cancels on the right, and we end up with 4x minus 4 equals negative 6. Let's go ahead and add 4 to both sides. And so on the left-hand side, it cancels. We end up with 4x equals negative 2. And then the last thing that we can do is we can divide by 4 so that we can get x by itself. And so we end up getting, just going to bring this up a little bit, we get x equals negative 2/4, but that can be simplified. We can take a 2 out of the top and bottom, and so we end up getting x equals negative 1/2. And so my two answers, x is either negative 1/2 or x equals 5. And for the last example, we have the absolute value of 3x minus 2 equals negative 4. So an absolute value gives me a positive number, whether it's negative on the inside or positive. So what we're saying is that the left-hand side, which will always give me a positive number, is equal to negative 4. But a positive number, no matter what it is, will never be negative 4. And so the answer to this is going to be no solution. Absolute values can never be negative.